Welcome to our webinar series for the 6th edition of Chemistry in the Community. Tonight we're going to look at Unit 4, Water Exploring Solutions. With me tonight I have two of our experienced teachers, Bonnie Bloom from Ohio and Debbie Pusatiri from New Orleans. And we're going to walk through Unit 4 with you as well. And we will answer any questions as we move along. So Unit 4, as we said, is Water Exploring Solutions. It is split into 4 sections. Section A is about what makes water unique. Section B, why do some substances readily dissolve and others don't. Section C, how do we describe the chemical behavior in aqueous solutions? And Section D, how is chemistry applied to produce safe drinking water? So I'm going to turn over the presentation to Debbie right now, and she's going to walk us through Section A and the unit opener. So thank you for joining us, Debbie, and I'm going to turn it over to you right now.
Great. Hello, everybody, and welcome to the presentation. In the unit opener, we are first introduced to the fish kill. And in this, they will read a newspaper article about how the fish kill is going on in Riverwood. And it introduces us to the topic that all of the unit will focus around. So looking at Section A, we start with what makes water unique. And the four goals listed are what we will focus on in this time, which is explaining the relationship between chemical structure and water and its unique properties, distinguishing the different types of mixtures, interpreting and creating models that represent the mixtures, and analyzing how our own personal and community uses water, including the introduction of direct and indirect usage. So in Section A1, we look at a town that's in crisis, and we can look at how we need to get enough water to supply our needs. And this is incredibly relevant in places like New Orleans when we talk about having hurricanes and being able to keep enough water. And it is also something you can bring into with what happened up in the Northeast with how do we keep enough water for our needs. And then also making sure that the water is sufficiently pure so it is something that we can use for bathing and drinking. And also looking at how fresh water is going to be one of those limited usage availability things that could potentially and will potentially outdo fossil fuels as a global economic issue. Now the concept checks you've seen before in other units. In this case, we're going to look at relating it to other information that they know from previous units, such as how do hydrocarbon molecules stick together, and then we're going to introduce that into how water molecules stick together. Then we're going to have them look at how the physical properties can work with how oil and vinegar-based salad dressings separate and what is a solution. Once again, we don't expect the students to have correct answers. We're just using this as a formative assessment. Now this chem quandary is probably one of my favorite chem quandaries, and it's looking at water, water everywhere. And once again, in New Orleans, this is something we know very well. But in this, most students are challenged as to where all the water usage happens when producing products. So you're looking at an egg versus a bottle of juice. And so it's a very challenging thing. You can use this as a bell ringer. You can use this as a discussion. You can use this in a group activity, individual activity. It's a great one, but I would suggest using this one. It's fabulous for getting them thinking beyond just the obvious. Now the uses of water, Section A2, this one really has them look at what their use of water is. They're supposed to look at households, how many people take baths, how many take showers. You need to make sure you do this relatively early in the unit. Do not put this off because it takes students a while to get the data. If you are not allowed to give homework, you need to make sure you have a valid data set available for them, because they will need to use this later in an activity. Plus, it also makes sure that they bring something of science into their everyday lives. So it's a really good thing to use. It also introduces some basic math concepts, so it keeps the calculation process available. Now, as with most of our units, we start off with an investigating matter. And this is a stations lab, which they've all seen before. It requires them to make predictions, which they should be used to at this point as well. And it introduces them to the physical and chemical properties of water. So there's lots of great investigative skills going on in this lab. It's very straightforward. The teacher's edition makes it very thorough, so it's a good investigating matter to start out with. Now in A4 we look at the physical properties of water, so we address density, melting point, boiling point, polarity, and intermolecular forces. We start to see how the structure of water affects all the physical properties of water. And here you have some great diagrams of how the water molecules bond to each other through their hydrogen bonding. Now in A5 we introduce mixtures and solutions, and they are introduced to the concept of heterogeneous mixtures and homogeneous mixtures. And here it helps to make sure you give lots of examples. If they've had some of the geography classes, not geography, some of the other classes, they may have introduced these in rocks, so they can pull other information here. Now A6 is representing mixtures, and it's a modeling matter, and they've done many modeling matters before. And in this case they're starting to look at how to draw representations of mixtures, looking at the homogeneous and heterogeneous mixtures. Now once again we stop at this point and they run into another concept check, so it goes back and has them review some of what they've done and also look forward to what is to come. So here they look at density again, and they discuss how different densities would show up in a graduated cylinder. They also need to look at densities and how they would be affected by different densities, such as floating in an ocean. It gets them to go back over heterogeneous and homogeneous mixtures and to make sure that they've understand what has happened before. And it also gets them to bring themselves into chemistry in everyday life by making them look at where they get their drinking water from. Now looking at graph A7, this is a great one as far as looking at and interpreting graphs. In this one they break the United States into different sections, and it's wonderful to get the students to look at why different areas of the country use water differently. And so for example, why is it that the West uses so much of the water for irrigation, livestock, and aquaculture versus Hawaii that doesn't need that much? So it's a great opportunity for people to understand the different uses of water in the different parts of the United States. Now in here in A8, they're going to look at their water analysis from the data that they collected in A2. Once again, students need to make sure they have this data in by this date, so make sure you double check your assignments and that they have time between A2 and A8 to collect the 3 days worth of data. So again, if they're not using data, pull out some sample data that you have collected. Make sure it's realistic. This is a great mathematical opportunity for them to use calculations and then to look at using a histogram for their information. Now A9 has a fabulous demonstration in the teacher's edition for this particular area as far as where is the world's water. Makes a significant impact on your students, and I highly suggest that you use it. This makes them realize that the majority of the water in the world is not fresh water and is not drinkable, but it also gives them a real perspective of where all of the fresh water is located. So make sure you look at the demonstration for this slide. It's wonderful. Now in river water, in A10, it's making decisions. And in this one, they start to analyze the issues between getting pure water versus getting clean water. And it also looks at where you would use your water if you had rationed water usage. This is something that brings it into their everyday life and really starts them thinking about where they use water and how much water that they use. So it ties in with getting them to think about the fish kill and what happens when they don't have water readily available. The next part is the Section A summary. It gets them to look at different things. So we wrap back to the goals section that is listed at the beginning, where we look at what makes water unique. So going back to the goals from the beginning of the unit, we are explaining the relationship between chemical structure of water and its unique product properties. So we look at strong hydrogen bonds between the water molecules. One of the next goals is distinguish between different types of mixtures. And so we look at how combinations of two different or more substances give you different types of mixtures. We also supposed to interpret and create models so that we can represent mixtures, and finally analyze personal and community uses of water, including direct and indirect uses. So one of the questions is wrapping this all up. It's a higher order thinking question where they're allowed to look at all of these various things they've learned throughout the section and put them all together. So that is Section A. And I am going to pass this over to Bonnie, who is going to do Section B.
Okay, let's take a look a little bit at Section B. And Section B is looking at what is in the water and why do some substances dissolve and others don't dissolve. So we're going to look at polar and nonpolar molecules. We're going to look at intermolecular forces. We're going to do a lot of modeling in this section using words, pictures, equations, how things dissolve. We're going to look at concentration. We're going to look at graphs and how different variables affect the concentration. We're going to use solubility curves, and then we're also going to look at the effect of temperature on the solubility of gases as opposed to the solubility of solids in water. So again, we start off with a concept check. Intermolecular forces, we have seen those before in earlier units. Solutions and suspensions, we just learned that in Section A. And now they want to try to have them modeling and visualize sugar and table salt dissolving in water. And what we're going to look at is what's happening at the molecular level as these dissolve in water. And this is where we're going to get into a lot of the pictures. So we start off with a lab, and it links in with the Riverwood fish kill. It involves a student designed procedure, and in this lab we're going to see what substances dissolve in water. So the students have to design an experiment figuring out whether a bunch of different substances dissolve or not. And then part two, what factors affect whether or not a solute will dissolve. So there are several different possible questions, and so some groups might look at the temperature impact, some look at types of ionic compounds, and for the ones that don't dissolve, they may look at other solvents. And this is a little different than the one that was in the older editions because this one really focuses on what's dissolving in water to make sure it's really linked in with the fish kill. And then we take a look at dissolving ionic compounds, and so we can see this picture of the little water molecules actually breaking the ions apart, and you can see the water molecules surrounding the gray cation or the green anion. This is sodium chloride, and it's supposed to show students that there aren't just sodium and chloride ions randomly floating around. They're floating around because they are surrounded by water molecules and the attractive force of the water to these positive and negative ions. And so we talk about the distance between the ions as attractive forces, the charge of the ions as attractive forces, and so we can look at that as a possible cause of our fish kill. And then we look at molecular compounds. And so it reviews ionic and covalent bonding, and it reviews what a molecular substance is, reviews polarity, and takes a look at the idea of like dissolves like. And I found that my students never really understood that until one day I figured out that they were talking about like as in you like someone on Facebook. So when I said similar dissolves similar, all of a sudden these light bulbs went on over my students' heads. I never understood why they didn't understand like dissolves like, but they weren't catching that like and similar are synonyms. So there's some nice illustrations talking about the angles and some of the vectors that cancel out. Even though carbon-oxygen bond is polar, carbon dioxide is nonpolar, whereas water is polar. And it uses some analogies, a tug of war, and then it talks about how nonpolar molecules dissolve in nonpolar and polar dissolve in polar. And now, based on this, we can go back to the lab that we started the section with and classify these substances that are molecular as polar or nonpolar. And we can look at does this apply to dissolving ionic compounds, and then it talks about the solubility of oxygen in water, which is going to become important later as we look at the fish kill. And then we're going to look at this dissolving process. And this is another modeling activity. And we're using chemical language to try to show a panel, a series, as things dissolve. And it shows an example. One of the people who I've talked to who've done this actually make it into a flip book so that they can actually see it. And I think there's some apps on the iPad I saw talking about one where you could actually turn this into a little movie. So having the students draw it and then actually turning it into a movie, if you have technology, could actually be a kind of fun thing to do. I've actually done it on large dry erase boards with my students working in small groups. But it really goes back to the idea of modeling, drawing models, and using representations to show what's happening. And now we get to solution concentration. My students have seen capital M, like, for example, a 2 mg CuCl2 or 0.2 m. So they've seen the capital M, and earlier I probably have mentioned, well, that means I'm measuring how many moles there is dissolved in a liter of the solution. But now we're actually doing some of the calculations. We're going to calculate percent concentration, parts per million, and molarity, and those are important later on as we try to look at the data from the fish kill. And molarity, we're actually going to do a lab. So first we're going to be able to do developing skills. We'll do some sample problems. We'll have some repetitive problems so they get to practice these several times. And like all the developing skills, there's always a sample problem showing how to work the solution out that the students can use as a model to solve their own problems. And then another concept check. So they have to, first one involves doing some calculations to try to figure out which solution is more concentrated. And the second one involves extending the knowledge in how are you going to make a dilution. And so that one's a little tougher for them. We haven't really talked about that yet, and that is something that's coming up. So here is measuring solution concentration. We introduced the idea of colorimetry, and we introduced Beer's law. We introduced the idea of a calibration curve and standards, and students need to make some diluted solutions. The instructions for colorimetry are really general, so it can work whether you have an old Spec 20, which still work great, or you use a newer piece of equipment, a colorimeter, a little spectrophotometer, whatever you use that can measure the right wavelengths, it'll work. And now we're talking about solubility of solids in water. It talks about a saturated solution, solubility curves, and we're going to be able to use the solubility curves to figure out how much of a solute will dissolve at a certain temperature per 100 grams. And so the next developing skills works through that. Sample problems with the calculations, and some of them are a little more mathematical, others are simply reading from the graph, and others involve some reasoning skills. So there's a bunch of different levels of questions in here. And then the next one talks about the solubility of gases in water. And so we can take a look at the idea that water temperature, that the solubility is the opposite for gases that it is for solids. And we can look at some demos. We can, I like to take a new can of ice cold diet soda and a new can of fairly warm diet soda, shake them up and open them. I find diet works better because then you don't have sticky residue to clean up everywhere. And then here is another modeling matter. So there's a lot of trying to look at the particulate nature and what's happening at the molecular level. So now we're going to find some new models with solubility and concentration. And so they will have to draw some models showing what happens when things are diluted, what happens when molecules are dissolved, and ions are dissolved. And then we're going to take a look at the idea of dissolved oxygen and the necessity for metabolism for different fish. So we're reading some graphs. And what I found fascinating is that there's a lot of my students that believe that the oxygen that the fish get comes from the water molecules. So we really have to talk about the idea that it's O2 dissolved in water, the nonpolar oxygen. And we talk about the limits and how much can be dissolved. Is there a lower limit of dissolved oxygen, an upper limit of dissolved oxygen? And then this is going to lead us back to the fish kill. So now we're going to look at the amounts of dissolved oxygen, and we want this is an opportunity for students to do a little bit of research. What are some scenarios not related to temperature that could lead to high or low dissolved oxygen? And based on that, what's more likely to end up to have happen? Are we going to have low or high dissolved oxygen? And then we're summarizing the polarity of water and its ability to dissolve ionic compounds. Whether or not molecular substances dissolve depends on the solute water attractive forces and the water-water attractive forces. We can calculate concentrations in terms of parts per million, in terms of percent, and in terms of molarity. We can use solubility graphs to take a look at how solubility changes over temperatures and looking at saturated or unsaturated solutions. And then we can look at the solubility of a gas depending on temperature. And then we go back to our starting question, and this is a writing prompt for students. And why do some substances dissolve and others don't? And we can focus on solutes, solubility, electronegativity, polarity, and concentration. And so this is a chance, another literacy piece for students to do some writing. And that finishes up section B. So now I will turn it back over to Debbie, who will walk us through section C.
Just a few comments to add to what Bonnie was saying in section B. As far as the fish goes, the fish that are introduced in that section is rather limited, and many of my students didn't know any of those fish. So I had to find fish that were local to our area and look at why they were different from other fish that might exist up north. And so we talked about, you know, the fish that and why when it got warm did some fish go one place. So there's a lot to do about looking at the metabolism of fish and the oxygen. And I can't reiterate enough what Bonnie said about students not knowing where the oxygen comes from. My students all thought fish had this magical process of taking in water and changing the water to breathable oxygen, and they thought that would solve some of our problems in the future. So it's something to really emphasize. Now looking at section C. Section C is where a lot of us as teachers go, hoo-hoo, we're into chemistry, though it's important to understand everything that we've covered in A and B to really get to the meat of C. And in C, we're looking at the reactions that happen in solutions. This is one of my favorite sections. So we're going to look at how we can describe the chemical behavior in aqueous solutions. So they're going to describe and write equations for precipitation reactions, which are always some of my students' favorites. They're going to use solubility rules that they just learned in section B to predict formation of precipitate and design tests so that they can for dissolved ions. They're going to learn to distinguish among strong and weak acids and bases. They're going to calculate and compare concentrations of hydronium and hydroxide ions and look at pH values in acidic, basic, and neutral solutions. We're going to talk about the effects of pH changes and how that affects various natural systems. And then we're going to look at the composition and chemical behavior of a buffer. So there's a lot that goes on in section C. So as we usually see, we start off with a concept check where we describe how is the process for dissolving, how it differs for ionic compounds compared to molecular compounds. Once again, this is looking at information they have learned from previous chapters. It's also a check to make sure they've actually learned it from previous chapters. Then we're going to look at what has greater influence on the effect of a solute in water, whether it's concentration or solubility. Then we're going to look at observable reactions and see if there's do they have knowledge of observable reactions between two different substances in aqueous solutions. Some people have. There are many students who have not. So in C1, this can be done on a very small scale, so there's not a lot of waste. It's very simple, it's very safe, and it's very, very effective. My students love this lab. So here we're going to take different aqueous solutions of ionic compounds, and you're going to use small amounts to see which ones produce precipitate and which ones don't. They create a data table that pairs up the solutions. Once again, this is something that they can do beforehand, and you can check to make sure it's finished when they come in. But this is a great lab, and it bounces off for many other things in this section, so you really cannot omit this lab. It's very critical for what comes up next. Now in C2, they look at precipitation reactions. So they're going to look at double placement reactions and how, one ion may move into the space of another ion. So we're going to look at a total ionic equation. Also, we're going to look at net ionic equations. We're going to discuss the concept of spectator ions and what those really mean. We're going to look at trends that led to our solubility rules, and we're going to use our knowledge of cations and anions that came up in Unit 1. So they're going all the way back to the very beginning. So you're going to need to keep those cation and anions back out, make sure they know what those are, because they're going to use those again in this section. So we're going to also use spiraling with metals like mercury, copper, lead, iron, and they talk about how they form cations with different charges. So we're pulling back a lot of information here to bring into our knowledge of precipitation reactions. So in C3, it's a developing skills. Once again, we're asking them to go through and apply their knowledge that they used in C2, which is their precipitation reactions. They're going to use that knowledge, and we're going to do some examples. Like Bonnie said, always they give you an example to model what they need to do in developing skills. And they're going to take the information that they learned from the investigating matters in C1. So using an actual lab situation, they're going to write their net ionic equations so that they can actually formulate the chemical equation for the precipitate that they saw developed. So they're taking a lab application, and it's not doing a lab on its own. It's using a lab in conjunction with actual knowledge that they're putting together and putting it all together in developing skills. So it's a great way to keep them involved with the lab that they've just done very recently. So it's really critical to keep that lab and all of this information in, because it pulls it all together for them. Now they also look at the reverse of dissolving in a pictorial fashion. So they're going to use a bit of modeling here as well. Now, so we just finished up looking at the lab from the solutions, and now we're going into another lab where we're looking at water testing. So we're building on what we learned in C1, that investigating matter. And they're starting to look at how we can use that knowledge to test for substances and ions that are in water solutions. So what is it? How do they know what's in the water? How can they test for what's in the water? And so it gets them thinking about how do these people actually do their jobs to see what is dissolved in the water. They look at confirming tests, things that they know can say that that's in it. They look at qualitative tests, qualitative tests. They're introduced to blanks and reference solutions, and they're introduced and defined. And students also learn that they need to use a blank as a control. Once again, emphasizing having a control-based lab, which is critical. And most students don't like the idea of control-based labs, but this is a great way of keeping it in their minds and in their usage, and it's a real hands-on way to do it. Then the next thing we get into are acids and bases in solution. They're introduced to the neutralization reaction, Arrhenius' definition of an acid. They are introduced to the hydronium ion and the concept of a reversible reaction. I find in acids and bases, people have a lot of knowledge, some of it which may be misinformation, some of it may have been taught wrong previously. So in this, you're going to have a lot of people who think they understand acids and bases, and you're going to need to make sure that the information they have is accurate and correct. So in C6, we have a developing skills. They apply the skills that they learned just in the previous unit in writing reactions involving acids and bases. They look at identifying the hydroxide and the hydronium ions. So they're using all that information that you just taught them in an actual application so that you can see how it's going and where they are and what corrections you might need to do as far as re-education of acids and bases. So then we hit a concept check. There's a lot of information that they've gotten, so now is a good time to try to step back and give yourself a chance to see how well they're doing. How can the student will be looking at how can they predict whether a precipitate will form. So they're looking at two different solutions of ionic compounds, and they're saying whether they can predict the precipitate. Then they're looking at a neutralization reaction as far as what are the reactants, what happens to the products, the properties of the reactants, and what are the products. And then we're introducing the new concept of acids are often classified as a strong or a weak acid. And it gets them to look at what is a strong acid and what is a weak acid, and why do you think this? Now, the strong acid and the weak acid always turns out to be the biggest struggle, at least in my class. So here we're going to look at C7. We're going to look at solution concentration and pH. So we define what is a neutral solution, acidic, and basic solution. They're going to look at the definitions of pH and the examples of concentration relating to pH. And then we're going to look at some of the pHs of common ions. This is great in a world that wants to get away from the chemicals that they buy in their cleaning products. You can look at some of these that are easily cleaning products available in your own home, such as vinegar. But it also gives us a chance to look at how pH affects your water ecosystems, which ties back in once again to the fish kill, is looking at how pH dissolves so many, affects the different fish and the different, products that are in our water. So again, it's a great thing when you have experiences like up in the Northeast with Hurricane Sandy. You can tie that in as to what was actually dissolved in that water, what came ashore. In New Orleans, we have very firsthand knowledge of that, and looking at solution concentration, how pH has affected the solutions. All of those things are very modern and real-day life for us down here. So now we look at interpreting the pH scale, and they learn the information that they learned in C7 as far as relating pH and concentration to acidic, neutral, and basic solutions. So they're getting some of this application in to items that are something they're used to seeing every day, getting a perspective of how this affects the ecosystems. Now C9 is making decisions, and it gets them looking at sources of acidic and basic contamination. So could there have been a source that caused the contamination of the Riverwood fish kill? Just within the last 2 weeks, we've had a fish kill here in the New Orleans area that was due to a release from a plant. So there are places around that will have these. Unfortunately, it happens more often than we care to enjoy down here. So it's always something for us that is available. And we have a lot of outdoorsmen and a lot of fishermen, so fish kills are pretty relevant. So students gather information. They look at how questions as to how they can define that, what affects what affects the different types of contamination could cause. It really gets them looking at it as far as how does the Riverwood fish kill relate to possibly a source contamination. So we've looked at acid and bases. Now we're going to look at the strengths of acid and bases. Now once again, this is where I always run into misinformation, and my students don't understand the difference between strong and weak and concentrated. So you're going to have to make sure you're pretty clear on this one, give them some examples, and maybe Bonnie has some ideas of how she handles it with her students. But this is always my area where it takes me longer than I usually expect, getting them to understand the definition of strong and weak.
One of the things that I find that helps is that strong and weak are often talked about as weak are partially ionized, and if instead of using that kind of language, you make sure you say only a small fraction of them are ionized, that seems to help. We can, because partial ionization, they think that the molecules only kind of break apart. The other thing that I've found that is helpful is a conductivity tester and a 0.1 molar solution of hydrochloric acid and a 0.1 molar solution of acetic acid, and to show them experimentally, we know they're strong and weak because that's what the data tells us. Look at how brightly this light glows. And now that we know that this is the data, this is how we interpret through this model what is happening. So that tends to help for a little bit with acid and strong and weak, but it's hard.
Yes. So there's just a couple of, Bonnie's got some great experience here. This is just always the one that seems to get my students. And once again, they have what they think of as strong and weak in their everyday world, and it doesn't necessarily correspond to acid and bases. All right, so in C10, they look at the relation of strong and weak acids and base solutions to their definitions, and they also start looking at defining and explaining a dynamic equilibrium, understanding that it doesn't just go in one direction, that this goes back and forth, that it is dynamic. Nothing ever just stops. So then we get into looking at strong versus concentrated, once again using a pictorial representation, using models to answer questions about concentration, pH, and other types of solution questions. This is something that for my students, once again, is challenging because it gets them to draw the models, but they really start to get there at this point because they've done a lot of modeling matters, they're good at drawing, and so this helps to click it for me. Then we run into another concept check. Seems that every time you hit something that's very, very difficult, the concept check pulls you back and makes you take a step back and look at what's going on. So in this one, it has them use their own terminology instead of that sometimes the science terms. Explain how pH is related to concentration of hydronium ions in an aqueous solution. And if you look at that sentence, it is packed with scientific words. So it's interesting to always hear what their words are, to take something that's a very small, simple sentence and put it in their terminology. The next one says, what types of particles would you expect to find in a concentrated solution of a strong base? Once again, going back to their understanding of the definition of a strong base. And then the last one, what type of substances might protect lakes and streams from the effects of acids, bases, and acidic precipitation? So it's moving them forward into the next section as to what can you do if you have acid rain. Students have heard about acid rain. Once again, I had to clarify to them that precipitation was rain or snow or sleet. So how would that happen? What can we do for lakes and streams, and what do some lakes and streams have that will help protect them? So that moves us into the concept of buffers. And so we introduced buffers that some lakes were not as affected by the acid rain. And what was it about those lakes that kept them from being so affected by acid rain? Then we look at defining, and they give examples of buffers in words and in chemical equations. So they have those that are reading, those who like the chemical equation models. It gives them an example of buffers in that situation. And also it takes, these concepts are being introduced because in the next section they're going to be doing a titration lab. Now here in C13 is an acid-base titration. So in this one you're going to need burettes, and I know that burettes are not available for everybody in their science labs. So if you can get them, you may want to choose to do this as a demonstration. If you do have them in your labs, it's a great thing. It's something that it takes a lot of patience. So it's a very useful lab to get done. Once again, some people do not have burettes available. Our lab did not have enough burettes available to do as a full lab, so we use this as a demonstration. Bonnie, did you?
Alternatively, you can, sorry to interrupt,
No.
alternatively, you can use syringes with a little stopcock on the end as a burette, or you can micro-scale it. It's a little better large scale, but you can micro-scale it and use droppers and count the number of drops if you don't have burettes.
All right, so once again, acid titrations are something that is often on standardized testing. Acid and bases are definitely on standardized testing. So this is a very critical part that they need to get in. You know, and using, once again, we're incorporating the concept of this lab using a titration in with acids, bases, and buffers, so they can see what they've just learned in action in the lab, hands-on. So now in C14, this is where they get a lot of information that they're going to use in the fish kill discussion. So they're going to get some study data that was just received regarding the water analysis from the Riverwood fish kill. There's lots and lots of data, so they're going to construct graphs from all of this various data. If you have a graphing program, or they have in the lab. You can use Excel. There's lots of different ways to do this. They can do the graphs manually. You can do the graphs on large graph paper data. I've done that so that they can stick up on the walls. But this is a critical part of getting ready for understanding the fish kill. Here's where they get all of the data and they start making the graphs so that they can interpret what those graphs actually mean. And it's a very critical point because they get lots and lots of information and they're totally overwhelmed. And if you can get them to start looking at it step by step, how they start to put it all together. So this is the best part. It is something that's going to take time. This is not a quick making decisions, so make sure you allot yourself plenty of time because this is going to provide them the guts of the information that they need for the fish kill, putting it all together.
Bonnie, I think we may have lost Debbie.
I think so.
Still there?
Debbie? Oh, she's offline. Okay, so I will talk about the summary. Our summary question is looking at chemical behavior in aqueous solutions. And again, this is a chance for them to do a little bit of writing. And so they're looking at precipitation, net ionic equations, solubility, weak acid and base, buffers, neutralization. There's a lot of chemistry here that lets them describe chemical behavior in aqueous solutions. Okay, let's talk about section D. Oh, before we do that, there is a chemistry at work section. And so this is looking at clean water, and so he's talking about analytical chemistry, and it's talking about using a sonofilter to purify water in developing countries, in Bangladesh and India, arsenic, and so he is using that as a way to make the world a better place. All right, section D looks at water purification and treatment. So we start off with an invitation to a town council meeting, and then let's take a look at the goals. We're going to purify some contaminated water. We're going to take a look at the hydrologic cycle, which most students have seen before. We're going to look at municipal water purification. We're going to do a comparison of different types of water purification. We're going to look at risks and benefits, and we're going to figure out what killed the fish and who is responsible. So again, we're going to start off with a concept check. What's a precipitate? How do we measure the pH? And why do we add chlorine to our water? So we start off looking at the data that we graphed in the last section, and we want to compare that data to EPA standards. So that will let us know, are we too high? Is it an issue? And we're going to keep that in mind as we go through the rest of the section. Then we're going to do foul water. In the older editions of the book, this was the first lab in the book. But now, instead of a cookbook lab, students have to design their own procedure. And they have to try to figure out, we've talked about solubility, we've talked about all sorts of different lab techniques. They're going to have to try to figure out how are they going to purify this water? How are they going to separate out the oil? How are they going to remove particulates? And how are they going to remove substances that make the water cloudy or smell bad? Or bad taste, but we're not allowed to taste the water, so we just describe that. Then we review the hydrologic cycle. By this point in high school, most students know this pretty well already, but we just like to emphasize the fact that there is natural water purification going on all the time, and so we can get clean water, so for thousands of years, water has been cleaning itself. But then we talk about how we need to purify our water, and it looks at the steps of each of these. There's some good little videos that show this. We used to be able to take a trip to see the water treatment plant in person, but now there's national security reasons, and they tend not to let people come in and look at a water treatment plant. And talks about what the different chemicals do and why they are used in treating our water. And then for this next developing skills, this is an exercise in looking at similarities and differences. I actually, for question 1, have that in the form of a Venn diagram, where I have them list the similarities in the center of the Venn diagram. And they're reviewing and going back to solubility and ions, and how could you remove different contaminants based on what you know about water purification. Another short concept check. What can we easily remove from contaminated water? What's disinfecting, and how is water treated at home? And then the next sections are disinfection methods and looking at risks and benefits. So we're looking at chlorination. We're looking at ozone. And so we look at the risks and benefits of what we learned to try to look at advantages and disadvantages of chlorine and ozone. And then we have a chem quandary. I like this chem quandary because students can take a look at the differences between bottled water and tap water. And I like to try to get some bottled water from a variety of sources so that we can see that some of it really is tap water from another city. Some of it is purified more than others, and we can take a look at what is the processing from tap water as opposed to the bottled water, and really gets them thinking about why we're drinking bottled water. And then we look at some home treatment options. We look at a water softener. We look at filtration, and we look at reverse osmosis. And then it talks a little bit about distillation. We used distillation earlier in Unit 3, and we talk about what that does to purify water. And now in this making decisions, students are assigned a role to play in the town council meeting. And so they need to find out what sort of background information they need. They need to know what kind of constituency they represent. What role would their group play? And they have to prepare for the meeting. What do they think the fish kill cause was? Was the crisis managed properly? And so they will either develop some presentation of data or some opinion, and they're going to make whatever visual aids they need for their presentation. So the summary, we're going back to the idea of mixtures, and we're using physical methods to separate them, and that's purification. We need artificial water purification because we keep adding contaminants, but there's only so much available in the Earth's hydrologic cycle. It talks about how we can purify water and how we can disinfect water for human consumption. And again, here's the writing piece. How is chemistry applied to safe drinking water? Steps in natural water purification, drinking water treatment, risks and benefits, and other ways water is treated. And then to put it all together, we have our town council meeting. And different students will have different roles. They're going to enact this town council. They're going to present evidence, and they're going to decide who is responsible for the fish kill and what are we going to do about it. And that takes us to the end of the unit.
Thank you, Bonnie and Debbie, and thank you for listening to the webinar. One of the things I wanted to ask was, what do you think are the most important things for students to get out of Unit 4, as well as what do you think are the benefits to having Unit 4 in this location in the textbook?
The benefits, that's easy. We can have a much more sophisticated analysis of the data and really look at what's contaminating the water in a much more sophisticated way than we could when it was at the beginning. We can really look at why do things dissolve as opposed to when it was at the beginning. Well, sometimes they dissolve in water and sometimes they don't dissolve in water. We can really take a look at ionic versus covalent, polar versus nonpolar, acids, pH, and I think some of the big ideas in this are some of the critical points. Well, being able to represent things in models are really important. Section C has a lot of heavy chemistry in it. pH, buffers, net ionic equations, precipitates. And Section B also does a nice job looking at concentrations and Beer's Law lab. So those are some of the big ideas. What's in the water? How does it, how do we describe what's in the water and what can we do with what's in the water? I think those are some of the big ones.
Okay. Did you have anything else, Bonnie, that you think would be useful for our users?
One of the things I hear the most is that people are nervous about doing a town council. If you take it seriously, and then the kids will take it seriously. And they can be great. And a town council success really depends on making sure you have the right, whether you want to make them the mayor or the council president or whoever you want presiding over the meeting, because it shouldn't be you. Picking the kid with the right personality to do that makes a huge difference. Another thing that makes things really nice is if you set up a video camera or have a friend videotape it while you're in there. Making a video of it makes it much easier to go back and look at what students did and so you don't have to worry about grading while you're watching it. And you can go back to grade. You can really just sort of be in the moment and focus on what are the students saying, how are the students behaving, making sure that kids are on task, they're answering questions, they're asking questions, and then go back later and look for more detail.
Do you find that your students are enjoying doing the town council meeting?
They love the town council meeting. They have a lot of fun with it.
Okay. Great. Well, once again, I want to thank you and thank all of you for participating, and please do not hesitate to contact us. If you have any questions, you can contact us at ChemCom, ChemCom, @ acs.org. And have a wonderful, wonderful evening.